Welcome everyone to another Pionix webinar. Today about the virtual charging park we're presenting. It's a perfect tool for testing your charge power management system with true EVerest-based digital twins. Before I get into the details, quickly, who's hosting today? We are Pionix. We're a startup founded 2021 in Germany, about 30 people. We initiated the EVerest open source project 2022. And yeah, we'll learn about that a bit more. And located southwest of Germany, we're hosting a lot of events around EV charging testing, and we're speaking a lot of conferences. And we are, in our words, building the foundation of charging from operating system on the firmware level to hardware components, good to build chargers. We built a special management solution for, let's say, second and third level support on the hardware. So it's not a CPMS, but more focused on debugging chargers. And we built this virtual charger park, and that's what we want to talk about today. Why is it important? Why do we have to talk about this? Building charge power management systems is difficult because all the chargers out there suck. I mean, that's why Pionix exists in the first place, to help that. But it's super slow and expensive to test all those different chargers, which are always slightly different in how they implemented certain protocols. It's a waiting game. You have to ship around hardware. You have to manually press button, plug in cables. If something ends up in the field which doesn't work, it gets really expensive because then you have not only to handle one charger, but a lot. Then you have so many different versions of chargers, of charger firmwares, of cars. And actually, you theoretically have to test all the matrix, all the combination of this. You have protocol deviations, as I said before. OCP is not always the same. Then you have error codes reported to the cloud. They mean different things, even on the same charger, just after updating a firmware version. You have connectivity issues. Yeah, and sometimes you have just broken things in hardware or in software. This is really painful, and we have a way to solve that, and that is the EVerest open source project. I will explain what that is because it's really the core of the virtual charger park. We build it around that, so it's really crucial to understand what this is, not only on a technical level, but also on an ecosystem or industry changing level. So let me start with that. What is the EVerest project? And afterwards, we'll explain you how we end up with the virtual charger park, so how this idea emerged, and then we will dive into demos, into technical explanation at the Q&A section. So if you look on the EV charging industry nowadays, it's super complex. You have like, in the future, with everything electrified, you will have billions of EV chargers of all kinds of shapes and forms and vendors and firmware versions. We will need billions of EV charging stations. You have thousands of different backend vendors, all having their own OCPP implementation, own SCPA implementation, and so on and so on. So then you have software quality issues, you have stranded assets, you have maintenance issues in the field, and you have, as I mentioned before, interoperability issues. So this charging industry is really, really complex. And how the industry currently tries to solve that is by adding more and more standards like OCPP, so the standard here in the middle, which you all talk. I think what we hear, 80 to 90% of the chargers are still with 1.6, which is now 14 years old. So the 2.01 version from 2020 around, which is 6-year-old, got almost no adoption compared to that. And let's not even talk about 2.1. So even if just adding more new standards to the game would be the solution, it's way too slow. Second, we have WAN standards. Every continent has a different flavor of the standard. Then we got a waste of resources. Everyone is implementing those standards individually. It's just a nightmare. And then you have dialects deviations. So OCP 1.6 charger from vendor A is not the same as OCP 1.6 charger from vendor B, even though they claim to be. We want to solve that, or actually we're solving that by unifying the operating system, so that across different vendors, you have the same firmware running on the charger. That sounds like a monopoly, but it's not, at least it's not an evil monopoly, because we're doing that with open source. A bit like all of your web servers are running Linux. I think it's safe to claim that, even without knowing you. You can do the same on the firmware side, so that all the chargers are running the same operating system underneath. And this is the core of what EVerest is doing, harmonizing that. It's a pretty good idea because there's a lot of things those chargers have to do. It requires a lot of firmware, integrating payment terminals, human interfaces like display, buttons, connecting to your CPMS, to the power grid, to local energy management system, to all the vehicles, and to all the components inside of a charger, from relays to safety switches to power supplies. All of that needs steering, and that's what EVerest is doing. And we're doing that hosted under the Linux Foundation Energy by a neutral body with a lot of participation. Come to that in a second. But the benefit from a technical side, as I mentioned with the server example, everyone uses open source already, also on the firmware level. There's Linux everywhere. Typical people adding black boxes on top with buying software component or hardware software bundled components, then they have to do a lot of coding on top. What we're suggesting is scaling up the open source process so everyone can use a common baseline, and then adding just a little proprietary software from the different vendors for things where it's really needed, where most vendors get unique, but the boring things like operating system, OCPP, ISO, where anyway there's no degree of freedom, at least there should not be any degree of freedom, we harmonize on open source. Because this is a huge ecosystem, we want to tailor everything from home AC chargers to public HPC charging parks. All of that should run with EVerest. We have a really sophisticated configuration management, so we can wire up different modules, we can configure modules, we have a language how to specify that in detail. That we'll come to that in the demo, but I think the core message here is this really scales also technically over the ecosystem. We are one of the biggest open source projects in the entire clean energy space or clean tech space worldwide. Just you can see here, the Linux Foundation says we're in excellent shape compared to our peers. It's really international from Europe, North America, quite a bit of India we see in the utilization, not in the contribution. Utilization is hard to measure, so it's blank here, even though we know there's a lot of things happening. It's really kicking off in ecosystem distribution, so we'll end up this year with probably 500,000 chargers. And it's really carried by a lot of vendors. So it's all the silicon vendors who are relevant in charging. It's all the big component vendors in EV charging, from power supplies to isolation monitors to controllers, working with many, many vendors. So here you see the tip of the iceberg. Most vendors are actually not public because they want to keep this private until they release. So we have some insights into that, but also not fully. And we're also engaging with the charge point operators, so companies like you and others here. Charge point operator engagement, that's basically the last of my introduction slides. In case you're interested and like this ecosystem, we think like that would help you operations here, or if you are close to CPOs, please sign up, join the EVerest CPO forum. We're meeting roughly once a month. We have all the previous meetings, or we'll have that online. There's a lot of materials, so the group here organizes and requirements, steers KPIs so that cross-vendor, this ecosystem moves in the direction the users, the CPOs actually require. So, but let's jump into the virtual charging park. So how have we went there? We started with this as being a pilot together with the Open Charge Alliance. They have the OCTT tool, the Open Charge Alliance Compliance to Test tool. I think most of you, or many of you, probably using that. It basically has two flavors. You can use it as fake charging station, then you can test your backend against it. You can also use it as a fake backend, and you can test your charging station against it. So, and OCA needed, basically as quality assurance, some, golden system under test. So some dedicated systems where they make sure everything works always fine with every OCTT release. And we, as Pionix, together with the EVerest community, contributed such a golden system under test. So OCA is now testing all their releases against the Pionix Virtual Charger Park. And that means implicitly that all the Virtual Charger Park releases are compliance tested by OCA even. And we also do those tests from our end. So this is really an industry reference. And the beauty for you is this is now also available for you to test your CPMS against it. So you have virtual charger parks. We dive into that in a second. You have test stimulus, and you can then try out if your CPMS systems work same way as the OCA is trying this. So let's dive into the virtual charger park. Let me quickly do a high-level architecture introduction before I hand over to my colleague Martin. The idea is we have a cloud environment, the Pionix Virtual Charger Park. Within that, we have EVerest instances, Docker containers. Within those Docker containers, we're running an EVerest framework. And this framework has a lot of different modules for authentication, for load management, for state machines, for OCP and whatnot. But it also has modules for simulating the ISO 511.8 side of a vehicle. It has modules for faking the battery behavior of a vehicle. So, and we internally between those modules really speak ISO 511.8 or DIN spec or whatever you need. So this is not just a shallow surface of a charger. It's really a full charging charger. It's a half a car, I would say. And we speak internally all the protocols. The only thing we emulate are the hardware drivers. So there's no real hardware module in it, for example, for RFID readers, but fake ones. And exactly those fake modules, like the RFID reader, is what you can utilize and control from your CI/CD with this automated test stimulus from this side. But enough theory. Let's jump into this. Martin, do you take over?
Yes. So hi, everyone. We'll come straight into the demonstration of the VCP. And first, we're going to start basically how do you set up the VCP and how do you get a charging session going with your own backend. So welcome to the VCP and the Pionix Cloud. Here we are quickly logging in and creating our first charger park. So we're going to create a simple demo park. And from what you can see here, we already have some template configurations that are ready to use, and you can use them out of the box. Today, we're going to set up a simple OCPP 1.6 charger. Here we have some simple configurations that you would need. So obviously, you need the OCPP backend, the security profile, the authorization key, the basic stuff you would need to connect to your charger, to your backend. You also have some other information that you can set yourselves, such as the station fuse limit, firmware version, EVC ID, model, etc. So you can really reproduce your in-the-field chargers. Once we've created that, we can get started. And here is the user interface for your single instance. So as we can see here, we started EVerest, and we can take a look at the logs, and we can see here that we have successfully connected to our backend system, which is Steve. And here we see that the number of charge points connected is 1. We have 1 connector that's available, and we can see that here, and we get all the information that we had configured previously when we set up the instance. From this view, we can also do some basic controls for the charging station, such as a plugin, like we just did. And we can also swipe RFID cards. And so once that's done, we can get started with a simple session and start the charging process. And as Marco explained, all of this is a real emulation of a real charging station. So there's real communication going in the background. In this specific case, it's just a simple basic charging session. But we can see here, again with Steve, that we have a transaction ongoing on our charge point using the ID tag that we had set, and all is well. So now we can come back to our dashboard, and here we can swipe the RFID again, unplug the EV, and that would be it for our simple charging session with the VCP. So we can do one final check in Steve to see that it's finished, the connector is finishing, and then we'll come back to our instance to finally unplug it and finish the small little demonstration of the simple setup and how to get started with the VCP. So the VCP, obviously, as we just saw, you can do some simple charging sessions, but where does the power lie for the VCP? Well, it lies in the fact that it uses EVerest. And since EVerest supports a very large feature set, as shown on the screen here, you can emulate anything that you want and configure it using OCPP and other configuration variables that we'll see later on. So as you can see, we can do OCPP 1.6, 2.0.1, and 2.1, and new features are being added all the time as EVerest grows and is developed. So as you can see on the 2.1 part, we have bidirectional power transfer that's coming and new DER functionality as well that's in progress. And all of that will be added in the future to the VCP as it's being released to EVerest. So on top of OCPP functionality, what else does the VCP and EVerest support? So as Marco said, there's it's not a simple like simulation of OCPP and a charging station and all that. It's really a full simulation and emulation of the communication protocols with a simulated EV, EVerest-based simulated charger, and you can do full sessions of ISO 15908-2-20 with flexible authorization methods such as plug and charge, RFID as we just saw, but also auto charge and local lists. And obviously the idea is that the VCP can be integrated just how you would integrate any normal EVerest charger into your backend system. So you could even imagine integrating it with some energy management systems or using some more complicated configurations and things like that, having it set as, for example, an AC/DC charger or other things like of the sort.
Yeah, and basically what this means for you is you have now all the scenario diversity where you normally need an entire lab with hundreds of charger types. You can just configure the types you need. You can basically crack through the protocol jungle. You can also emulate, let's say, legacy protocol versions. You can also soon select legacy EVerest versions. You can really get to the long tail of edge cases. You get rid of a lot of hardware. So this scales up. We come to that in a second. And end of the day, this is protecting your product, your brand, your reputation, your budget, and also makes you faster, especially around in the AI age. Everything what you can test automatically works better with vibe coding. And now you have a perfect tool for testing way much better automatically. And yeah, let's go further details. So how we scale this up, how do you get to more scenarios?
Yeah, so taking it back from here, so we showed how to set up a simple session, and now we're going to dive a little bit deeper into configuring really more EVerest and how you want to expand that to your actual needs. So to dive a little bit deeper here, we're going to present to you like how you would go ahead and change the EVerest configuration. So here we have the config explorer, which allows you to look at the EVerest configuration. And here what we're going to do is we're actually going to extend the configuration template that we had to create a dual socket AC basic charging charger. So here, what you can see is I'm just copying the appropriate modules and renaming them and changing the configuration to properly align with the EVerest framework. And so here what I'm just doing is I duplicated the EVSE manager, which handles one specific EVSE, the EV manager, which is a simulated EV, and all the simulated drivers that go with the EVSE manager. And so as you can see, there's quite a bit of knowledge required, and all of this can be found online on the EVerest tutorial pages and on the documentation. But if you ever do need some help with this, Pionix is here to help you get started and reproduce your actual park quite easily. And so if we continue with the configuration, quickly skipped some of it because it is a bit long. And so here we've finished making our changes. We apply them here through the config explorer. As it says, we should wait a little bit, but to go a little bit faster, we're going to just recreate our VCP instance to get started with our dual socket AC charger. And now we're just going to wait for it to come back online. And once it comes back online, we can start playing with it and start using our dual AC socket charger. So we see it's come back healthy. We see our new user interface. I had previously changed it so that we have 2 chargers available in that user interface. We will see afterwards how to change that very quickly. And as we saw in the logs, we can now plug in and start charging our dual AC socket charger. So here we see we swipe the card for the first RFID and we plug in the second one, and we're going to use Steve now to remotely start the charging session via an OCPP 1.6 remote start. And so here we're just going to use a new ID tag, set it for the second connector, and start charging on both connectors. And then we can see that happening in our new user interface over here. And now we have both sockets charging at the same time. So really the idea here is that you can change your EVerest configuration to match real life, to match any configuration that you need. You could make this AC-DC, DC-DC, whatever you need, high-level charging or not. And here we just did a quick presentation on how you would extend the functionalities to suit your needs. And so coming back one step behind for the configuration of this user interface. So as you can see here, we have this dashboard. Before we had 2 boxes for the 2 connectors, and you can actually go into the Node-RED editor underneath and create your own little Node-RED flow so that you can extend this user interface to the actual EVerest configuration. All of the templates come with the associated Node-RED flows. So if you do modify your EVerest configuration, then you need to actually update your Node-RED flow to match that and be able to control via the user interface your new charging station configuration. Without it, you'll have a few difficulties setting it up. And we'll see later, obviously, this user interface might not be the most practical, especially when you scale. And we'll see later how you can actually control multiple chargers in a more programmatic manner. All right. So now we're going to show another presentation on how to set up a quite important feature, which is plug and charge. So as you saw with some of the templates, some of them were marked as plug and charge capable and some were not. And this is really based on some of the configuration in EVerest. And so we added those and pre-made those to simplify your setup already here. The only real thing that changed here is this cert install needed dropdown, which really just means if you want your plug and charge capable station to install the contract certificate in the EV via ISO 15118 and OCPP. So here we created a new demo park that's PNC capable. And here we can enter our user interface again, and we see that we have a little bit of a different instance here because we have the connector 1, which is ISO 15118 capable. Looking through the logs, we can see that the station has come online, and now we can try to do a plug and charge session. All of the instances come with the EVerest fake or test certificates that are already in the repository. And so here we do a plug and charge session, and you can see that the ISO 15118 communication is starting through the messages. And we can see here that a plug and charge authorization was received and that it was accepted, and that we are now in the charging status loop, which means that we're actually charging. So here we can see that we can easily get set up with plug and charge with the VCP and EVerest. You can either use the certificates that are already there, and you can get those as well through the EVerest GitHub repository. Or if you want to use your own certificates, you can do the cert installation process via OCPP and ISO 15118 by setting the flag to true that we saw earlier. But what you can also do here is you can actually upload your own certificates via the Config Explorer. And we have a small tutorial on the VCP on how to do this. I won't go into great details about how this is done, but at the end of this page, there's actually a part right here where we see the certificates folder structure and which ones should be uploaded to their VCP instance to be used for a plugin charge. And obviously, if you ever do encounter any issues, Pionix is here to help you get set up easily.
Thank you so much. So let's look into how to scale up those charger parks to more than one charger. Lucas, will you take over here?
Yes, we have already seen a lot about how to configure individual chargers. Let's test our backend with a lot of them and see how we integrate this into tests and everything. So we now did a lot of manual steps on interacting with these instances, but what you usually want to do is you want to interact via an API, and that's what we have. Every instance comes with its own REST API, which you can call and execute stuff like plugging in the vehicle, doing authorization and everything. And we have made a little example repository to guide you through that as well, which I will show later. And also some stuff around integrating this into your CI pipeline so that you can have an instance whenever you need it and not anywhere else. So let's have a look on how this actually works. We have this repository VCP examples, and in that we have a few Jupyter notebooks. And to start, we want to generate a lot of different values for varying charging stations. And we have a little example here in which does exactly that. You can tweak that, play around with that in your browser. And I will set this to 500 charging stations here and run this. And what it will do is it will ask me again for the URL of my CSMS. Let's paste the URL for Steve here again without WSS in the beginning. So leave out the protocol here, and it will generate config files and give me a list of generated serial numbers in this case. And if your CSMS needs it, Steve does it. You can copy these and paste them into your CSMS so that they are added already, which we will do now. And add them to Steve here. And yeah, you've seen I've already done before, but here you would do that, and then we have all the charging stations pre-configured here, ready for them to come online. And what we now need is the CSV file, which was generated here. You can find it in the files and the output folder here. We can download that, and we will upload that in the cloud in the config placeholders editor. That's where we can configure placeholders, which are then configured on each of those instances, and we can see a lot of varying firmware versions, different models, whatever, everything pasted in there. And because we are in this case using the charge point serial number as the charge point ID for OCPP, we will also have to change something in the templates, and that shows you how you can even use your own placeholders there and extend this. It's just a table in the end, and here we are replacing the charge point ID in the OCP16 config of EVerest with the charge point serial number placeholder, and then it will use that. So let's do that, apply changes, and when we now restart the charging station, EVerest will pick up these changes we did there, and after a few seconds we get a new running EVerest instance now with the new values provided, and it's connecting to Steve again, and we will see it appearing there. We already had that, but now with the new config files, that is working on one instance. So now we can simply scale it up by using the scale functionality here. And yeah, we can type whatever number we want here. In this example, 50, and it will start up 50 instances. And you already see the API URL paths here. They are blurred out, but you can reveal them as well. And yeah, then you have a lot of those instances which are connecting to Steve as well. We refresh here. We see them all online. So that is working. We can even use higher numbers as well, depending on what you need if you want to do a load test and everything, scale this up. But I will skip this part now because we have already seen that. Now we have created a lot of instances which are running. How do we control so many chargers now? Again, we can take a look at this repository. We also have a Jupyter notebook for that as an example. Every instance has a REST API. We have seen those URLs in the web interface already. And what we are doing basically is we are, does it autoplay? I think the video doesn't play.
Let me play that one.
Thanks. What we can do, we can have a look at this API here. There you can click on it in the web interface, and our Jupyter notebook just uses this API and asynchronously talks to all of the different instances. What we will just do is we will run this notebook, and the first thing it asks us is the instance IDs, which we will copy from the web interface of the cloud. So we will just grab those here, copy all instance IDs, paste them here, and it asks for valid auth ID. You can use one we have previously set up, and then when we execute this, it talks to the API and runs through all the different instances, runs a session there. But you can configure whatever scenario you want by just calling the different API endpoints. Another feature which is coming really soon is the ability to easily get a temporary instance while your CI pipeline is running, because likely you want to test continuously, not only for once in a time, but for example, on every pull request you make. Through what we made here is, as an example, a GitHub action. If you're interested in other CI solutions, please contact us. Then we will build better integrations for those as well, but it's actually pretty easy. So what we have is a little CLI for the Pionix Cloud, the PC CLI, which authenticates via an API key. I will later show as well how you create that. And inside this GitHub action wrapped here, this is executed in the end. If you use any other solution, you just use the PC CLI raw directly. We have that documented in the documentation. But what it is doing here is you give it a template of a virtual charging park we created earlier, and you give it the amount of instances you need during this test. And then what it will do is it will create this virtual charging park as a temporary virtual charging park with those instances, and it will give you back the instance IDs of those parks, of those instances, and then you can run your tests against them. At the end of the workflow, when the GitHub action stops, it is automatically cleaned up again, and everything is stopped again. So that's a pretty nice way to continuously integrate here. And this is how you create the API key. You just go to your profile settings in the API access, generate yourself an API key, and you can use that with the PC CLI easily. Marco?
Yes. So, and there's another preview, what will come publicly in 2 months, but people can already get beta access. I mentioned initially that we have not only this product, but also others. And one of that is a Charger Developer Cloud and Charger Maintenance Cloud. It basically lives next to CPMS and really focuses on debugging a charger, like getting SSH access to that, in the future getting screen share access, crunching EVerest-based log files, really understanding the log files. So it's not about payment, it's not about authentication, it's not about managing a huge fleet. It's just there for debugging. We also will have API access for other CPMSs to integrate. And the beauty is you can even try that out with the Virtual Charger Park. So you can use that to escalate a charger and connect it to the CDC. And we will have a deep dive webinar about this after the Power to Drive. I will officially launch it. If there's any EVerest team here in the room who want to try it out already, just give us a ping. And I will leave to Lucas for the live demo now.
Yeah, that's a pretty easy one. You can also connect the instances to CDC directly when you have access, and view it inside the CDC and use a lot of the functionality the Charger Developer Cloud has. For example, you can initiate an SSH connection and just SSH into this running instances, into this running instance here, and yeah, then you should have access. Let's copy the SSH command here, and it then goes through a proxy we have, and you have access to the running instance.
Thanks a lot. So let's go to wrap this up. If you look at the Virtual Charger Park from a high level, how does it compare to everything else in the industry? I think the obvious question is, does it compete with OCA, OCTT, or is it complementary? And we think it's really complementary. If you look on OCTT, it doesn't allow you freestyle testing. It's just really, really good, and the best you can get in the official reference set of test scenarios, like do this, do this, do this, and you can go through flows. And it perfectly prepares you for certification or for pre-certification, but it not allows you to play around freely. You can go with lightweight simulators. They're really good if you just want to scale up to 100,000s or to millions of chargers. It would get really expensive with our solution to launch so many Docker containers. There's also fleet and energy simulators out there, which are really good to predict or emulate real user behavior at a supermarket in the Saturday afternoon. What will be the coming, going pattern of vehicles? It's also not VR form. What really EVerest is great in being as realistic charger as possible with all the protocols, all the behavior, all the quirks of the different protocol layers. And you can do that with EVerest, do it yourself, but then you have no support, no CI/CD tooling, you just have the code for one individual chargers. And what Pionix Virtual Charger Park then basically wraps around this is the scalability, the managed service. So it's perfect for really stress testing your OCP implementation, stress testing your plug and charge, stress testing whatever comes there, and all the other things. We will have the Virtual Charger Park now available. You can just sign it up. You can get a free trial on it. Just go on cloud.pionix.com. If you need more than 500 instances, give us a ping. So we're happy to talk to you and launch with you the commercial version, which then enables you up to 10,000 chargers, even more than 500 simulated hours. And this is all the features we just explained to you. There's another upcoming webinar, actually, besides the Charger Device Cloud, which I already mentioned, and that's around software-defined charging, because that goes way beyond this cloud. It also goes really into the hardware architecture and how you can manage those chargers, how they are future ready, how they're over-the-air updatable, how you can reduce CapEx by having proper charger architecture software-defined. And that's it. So please get in touch with us, schedule a session, join one of the future webinars. Software-defined charging one we will announce as soon as we have the final time slot. Will probably be like 4 weeks from now, and just get started with your Virtual Charger Park today. And I would now love to open up the Q&A. So let's see, I think some people raised it here in the chat. So the next one would be, does the Virtual Charger Park support smart charging profiles? That would be on Martin, I guess.
Yeah, so just to quickly answer the question, yes, we do support smart charging profiles. We're actually certified for it with EVerest on 1.6, and we have several customers that are certified 0.01 as well using EVerest. So we support it in both 1.6 and 2.01. And currently we're extending the functionality for bidirectional in 2.1.
How do you simulate different charger behaviors per vendor? Going into that, we are basically, we can have different EVerest configurations. So there's different flags on timings, on should you stick to a standard, or should you try to charge a Tesla? Should you stick to a standard, or should you try to charge a Kia vehicle? So there's always quirks those different vehicles need. You can configure all of those quirks. Different vendors will have different EVerest versions. They will have different setups. What we're not emulating is, like, let's say, if you have a certain power supply, we just have one fake power supply where you can configure what is the power level it can create, for example, for a DC charger, but we're not going into detail to also replicate the hardware in very, very detail. So for us, different hardware components have certain parameters. That's what you can configure. And as again, if you want to replicate something special, it should be rather simple with a template editor. If you want to have more details and more power, just reach out to us. We know the EVerest configuration is very long, but it's super, super powerful. If you need help, reach out to us or to the EVerest community. Next one is, with a large number of chargers, can I set up different flows per charger? Yes, you totally can. Markus or Lucas or Martin, you want to have any comments?
Just a quick explanation there. You have seen for every instance, you get an ID. And what you do is you just talk to the API of each instance and use whatever AI you like and give it the Swagger JSON, which you get via the web interface easily, and tell it what test scenarios you want, and it will happily generate you all of the different scenarios, and you just execute it against that, and it should work. So that works really well. We did that a lot in our testing, so that doesn't take much time.
If there's no further questions, feel free to reach out to us. We will publish those slides in the recording afterwards. Yes, we will share that. Thanks, René, for asking. Give us until tomorrow, then everything should be on YouTube on the slides, and we will send that to all the signups of these meetings. And talk to you soon. See you soon. Have a great week.